Hello students, welcome to class 11 physics. Let us solve the textual illustration of chapter number 6, work, energy and power. So illustration number 5. A woman pushes a trunk on a railway platform which has a rough surface. She applies a force of 100 Newton over a distance of 10 meter. Thereafter, she gets progressively tired and her applied force reduces linearly with distance to 50 Newton. The total distance through which the trunk has been moved is 20 meter. Plot the force applied by a woman and the frictional force, which is 50 Newton versus displacement. Calculate the work done by the two forces over 20 meter. So here first we need to find the total work done. As you can see over here, the force applied is 100 Newton up to 10 meter. After that, the force reduces to 50 Newton up to 20 meter. So the total distance covered over here is 20 meter. And the force applied for 10 meter is 100 Newton, and after 10 meter to 20 meter it is force is 50 Newton. Now here the trunk is being pulled up to 20 meter on the rough surface. That means the frictional force is applied by the rough surface and the frictional force is 50 Newton. That is, it is opposite to that of the displacement. So here frictional force magnitude is 50 Newton exerted opposite in force and opposite the motion. So it is the negative side of force. It is shown in the figure. Now here, as you can see in this graph, the work done by the woman is, here you can see the area of the rectangle, that is ABCD, and CEFD or CEID, that is the area of the trapezium. So the total work done is the area under this figure. So work done is area of rectangular ABCD plus area of trapezium CEID. Now rectangular ABCD, that means length into breadth, that is AD into AB, plus trapezium is half into CD plus EI into DI. That is, now AD over here you can see it is 10 meter, AB that is 100 Newton, plus half CD over here, that is again it is 100 Newton, EI that is 50 Newton, and DI over here, that is this much distance, which is 20 minus 10, that is 10 meter. So when you calculate this, you will be getting 1000 plus 750, that is 1750 joule. Now work done by the frictional force. Work done by the frictional force is area of rectangular AGHI. That is this AGHI. This area will give you the frictional force, work done by the frictional force. So it is nothing but AF into AG. You can write like that, that is AG into GH. AG, that is minus 50 Newton, into GH, that is the distance 20 meter. So minus 50 into 20, that is minus 1000 joule. So work done by frictional force is minus 1000 joule. The area on the negative side of the force axis has a negative sign. So students, you may copy down this numerical. Now let us solve illustration number 8. To simulate car accidents, auto manufacturers study the collisions of moving cars with mounted springs of different spring constant. Consider a typical simulation with a car of mass 1000 kg moving with a speed 18 km per hour on a smooth road and colliding with a horizontally mounted spring of spring constant 6.25 into 10 raised to 3 Newton per meter. What is the maximum compression of the spring? So here at maximum compression the kinetic energy of the car is conserved entirely into the potential energy of the spring. Thus, the kinetic energy of the moving car is, we know the kinetic energy formula, that is K equals to half mv square. So here mass of the car is given as well as the speed is given. Here speed is given in kilometer per hour. So let us convert that into meter per second. So converting kilometer into meter, that is 1000 meter upon 1 hour becomes 3600 second. So when you calculate this, you will be getting speed as 5 meter per second, and substituting that in half mv square formula. Half into mass is given as 1000 kg. So 10 raised to 3, we have got as 5 meter per second. So 5 square. When we calculate this, we get 1.25 into 10 raised to 4 joule. From the law of conservation of mechanical energy, potential energy of spring is equals to kinetic energy of the moving car. So we can write U equals to, over here we are writing V equals to half kx square. Here K is the spring constant and xm is the maximum compression. So taking half mv square, that is the kinetic energy, is equals to the potential energy, because the kinetic energy is totally converted into the potential energy. So we can write kinetic energy equals to potential energy. Here K equals to V, and K we got as 1.25 into 10 raised to 4 joule, and V is half kxm square, and putting the value of K and xm we need to find. So half into K is 6.25 into 10 raised to 3, and here xm square we need to find. So taking xm square as the subject and taking all the other terms on the other side. So when we calculate this, we get xm square equals to 2 into 1.25 into 10 raised to 4 upon 6.25 into 10 raised to 3. So taking root on both the sides and calculating, we get root 4, that is 2 meter. Thus the maximum compression of the spring will be 2 meter. So students, you may note down this numerical. Now illustration number 11. An elevator can carry a maximum load of 1800 kg, that is elevator plus the passengers. It is moving up with a constant speed of 2 meter per second. The frictional force opposing the motion is 4000 Newton. Determine the minimum power delivered by motor to the elevator in watts as well as in horsepower. So here we know we need to find power, and what we are given is the mass and the speed. So from that we can use this equation as P equals to Fv. So first of all we need to find the force, because speed we are already given in the data. The downward force on the elevator is F equals to mg plus F, that is the gravitational force and the frictional force. So the total force, that is mg plus F, where mass is 1800, gravitational acceleration here we are going to take as 10, plus frictional force, that is 4000 Newton. When we calculate this, we get 22,000 Newton. Thus, using this formula P equals to Fv, we can write 22,000 into 2, that is 44,000 watt. We need to convert that into horsepower. So dividing by 746, that is 58.98 horsepower. So we get power equals to 59 horsepower. That is, approximate value is 59 horsepower. So students, you may note down this numerical.